like it can go really long, as we are going to see this afternoon with a TensorFlow definition file that is like biblic definition file long. But the idea is on the Bootstrap, you can point to different sources from which you're going to grab the file system, right? So here on the Bootstrap, you can have Docker library. When you say library, you're pointing to the Sylabs library services. You can also point to Yum repositories, Debian repositories. You can point it by using Docker. Here in the form, you can point it to the AWS Container Registry, Google Container Registry. With the upcoming version of Singularity, the 3.3, I guess is going to have that feature. You can point it to the Microsoft Azure OCI Container Registry, which is called ORAS. So you can point it to ORAS here. That is really amazing for the Azure people. Then we have different descriptors for sections, right? So kind of.
Oh, sorry. There is a directory or some place that I can check the list of sources, or is
yeah, in the documentation of Singularity. So, and text that you say a directory. Also, the Bootstrap can be pointed out to a local existing container that is already in your host. So you can build containers from containers that you already have.
So this is going to determine the system right?
No. Here we are pointing to the library.
Okay, well, this is, I am coming from example directory, and there is CentOS.
Oh, because I created caches, local caches in the AWS.
That's the same as the host or the system or not?
No.
This is the West in the container.
Which is independent totally.
Yeah, it's independent. That's why it says from. It's from what it is here. It is going to be really fast in the AWS instances because I already cached Ubuntu, CentOS, and other things. So here we have different descriptors. You can have run script, post section, pre sections, setup sections, label sections, help sections, and test sections. And where all the magic of what is going to live in the container after it's built is happening on post and in run script. So this is why here's the example. You can have a setup section that is really something that you want to do before you start running building the container. So maybe you want to pre-get some sources or something like that before really going into creating a container. And after this, you can also use the test section to test everything that was built in the container, right? So this is how, like, kind of a lightweight CI implementation when building containers. So you can build your container and test it. And if the test fails, Singularity is going to yell that the test failed and remove go back to the beginning because the container was not passing the test or something was wrong, right? So there are a lot of sections in the definition file that you can use. Here we're going to start really slow, one-on-one, is building a local container, installing that Beam, like you don't need much inside the container. So let's everyone start doing this in their AWS instances, and I'm going to be going section by section here. So after everyone creates the Beam, if you need help exiting the Beam section, please let me know. And after we run this, we're going to move forward. I'm going to give this small section like 2 or 2 minutes. I'm going to count 3 minutes so everyone can create the Beam file and run the sudo singularity build. My fault. You do sudo user local Beam singularity. I don't know why AWS is doing that. I configured the instance to have singularity on the path for sudo. If it is not finding singularity on the path, you can do user local bin singularity, the full path. Could you give me the last number of your instance?
No, this is not the instance. This is a new machine. Let's start singularity as my person.
Oh, that's not AWS?
No.
Oh, that's why.
But I follow the instructions. So I'm following this tutorial until the point where it's working.
Yeah, no, it goes with the which OS is that?
And no server.
Yeah,
Which I think
that only happened with CentOS 7 and Red Hat 7. With Ubuntu and other OSs, it goes into the path.
Because user bin is not
Yeah,
in part of
the
the
path.
So a quick explanation while everyone gets into the same section. When we are doing a -- sandbox, we are not creating the binary file that I talked in the initial session. We are creating a folder with the file system, right? So by default, if you don't use sandbox, if you don't use the sandbox flag, it is going to create a read-only file, right? Like a binary file that is read-only. So for development purposes, if you want to work in your container without creating a read-only file, then you use sandbox. Then you can do all the features and capabilities of Singularity with the sandbox. The thing is, we do not recommend sandbox for production, right? So every time you work with sandbox, it's for development only. Then when you're happy with your sandbox, you can create, as I was explaining, that you can create containers from existing containers. Then if you're happy with your sandbox, you can create a zip file or a Singularity image file from that sandbox, and that becomes a read-only container. So why having read-only containers is that a lot of the exploits that are happening right now in the container ecosystem are really because containers are not read-only. So if you can start doing things inside the container, then you are opening yourself to some security issues. By having a read-only container, then you are protecting yourself from some security related to writable containers, right? So again, as I'm saying, with sandbox, you can show it to the sandbox, run the sandbox, move it around. Like it's a regular Unix folder with a lot of files in there that Singularity can just read to generate a container from that. But again, it's a folder with a bunch of files that whoever else is in that same host can modify some files there. So it's not secure. So here what I'm showing really is that, well, this is outdated because I'm using the latest Ubuntu now, but that the AWS instance that you are running is a CentOS instance, but when you are running a process inside the container, you are running a Ubuntu process. So that's really this picture of it. It's not Ubuntu 14 now, it's more than that. These are two interesting commands that are really here to, if you want to also play with that, is show how you are the same user inside the container and outside the container. So if you run this inside the container, like shelling into the container, you're going to be the same HPC user number, whatever you are inside the AWS instance. So let's say you are user number 2. So if you say, who am I, it's going to say HPC user 2. Right? So you are the same POSIX user with the same POSIX permissions that HPC user 2 has. Now, it is assembles. So again, it is a writable file system. So if you want, you could do a sudo apt-get and start installing things and start creating things inside that container, and Singularity is going to allow you to do that. So here what I'm showing, well, the sudo command is not there, but what I'm showing here is that you can write things into your container, right? So it's not really on. This line, what I want to show here is that a lot of container optimized file systems do not come with sudo by default. Because by default, they think that you are root. So there is no need for a sudo command if you are root every time. So for doing apt-get and different installs into the container, you need to go out of the shell instance that you are running in Singularity. And when, big warning, we're going to be using sudo, you do sudo Singularity shell container, right? The path of the container. Then you don't need sudo inside the container. You can just start calling things inside the container, and you are going to have admin root permissions inside the container. Then you can call apt-get or jump or zipper to stop things inside the container, right? Big warning, remember, if you are using sudo, you are sharing the same VM with different people, so everyone is going to be running sudo at the same time. So that's why I'm showing this here. A lot of time people, sure, one second. A lot of time people hard code the sudo word into bash scripts and things like that, and they try to run that inside a container and that fails. And when you start debugging, really the fail is because they are calling sudo hard-coded. You should not hard-code sudo, because sometimes you can just call the container as sudo, and you remove hard-coding the sudo command inside the container. Yes?
I have a question. When we did Singularity build with sudo, we gave a name to the container called how. Is this name shared between all of us or in Amazon?
No, because the file is going to be dropped in your home.
Okay. It's in our home? Okay.
Yeah, the sudo is really because you are performing installation steps. apt-get, jump, these kind of things. If you don't do installation step, you can code that without sudo. But at the end, the file, the resulting file, is going to be living in the, not even in your home, in your PWD, right? So whatever you are right now, PWD, the file is going to end up there. Do you see the file there? Yeah, it lands in your working directory. So here is what I was explaining about calling Singularity with sudo outside Singularity. So we can move fast here. Are you starting the bootstrap everywhere?
Yeah.
Guys, okay. So here is a much bigger container definition. As I was saying, you can have different sections. Here we have a new section called environment. So a lot of times, maybe with things like WRF, Kenneth's favorite application. you need to set up a lot of environment variables in order for your app to run. And a lot of times that is really hard and you need to do it at runtime. So what is really going to happen with this environment section is that it will become a bash file living inside your container that is going to be sourced every time you run the container, right? So here you can declare a lot of exports, but also you can have a small bash scripts that maybe need to build an environment variable at runtime, like the time, the date, or wget something and source it before running the container. So this environment section is going to set the environment of your container at runtime. And how are we doing that? This will become a bash script that is going to live inside your container. So this is what I say, that the container is also carrying around the metadata of how to run that container, right? So you not only have a file system with your application, but also you are moving around in that container the how to run this container. And all these sections are going to live inside the container as bash scripts. The run script, what it means is what is going to happen when you call that container by default. So there are three ways of calling a singularity container. You can show into the container, you can exec whatever binary inside that container, or you can run the container. So Singularity gives you three ways. Singularity show, exec, run. When you run, it is calling this scriptlet here. If here you set ampersand add, you can then Singularity run your container in a parameter or an ingress or whatever. If you don't set a bash ingress, whatever you type after Singularity run container name is going to go null, right? So here, if you call this container, every time it is going to create the count, right? So 5 minutes. So we can create this and run Singularity, run this file, and see that it generates the count. It should be less than 5 minutes max. So, okay. Can you run? Yeah, 5 minutes to build this and get the count that is generated by running this file. Questions?
So what you need to change, the problem seems to be your mouse. This one pulls in an image called Ubuntu latest from the Sylabs library. There's something broken in that image. Somebody broke something there. And where's the
Up there.
yeah, so this one needs to change. Latest needs to become 18.04. And also you don't need whatever the fuck this is. So if you just refresh the page.
Oh, that was really an example of how you change things.
Yeah. If you refresh the page, this is what it should be for the very basic example. Use a specific version here and remove the set magic line, and this should build.
And also for the biggest.
Yeah, I'll change it for the other one.
So here, people having the problem with the libc, we should change it for 18.04. Why libc is not working there? Still is here. Question not related with libc.
Oh, the music. Some way, somehow, it does not found Fortune package on the 18.
For this example.
Mm-hmm. That's why you love package managing.
That's why I don't containers to easy to
People move things where they should be. Okay, now if
That means that you have a read only container. If you run the inspect --def file, and this is when you get a container from another person, and this is a good practice of building containers. So if you build your container from a sandbox, this is not going to happen. That's why I always tell people sandbox is for playing, for developing. But at the end, best practice should always be to create a good definition file and build your containers from the definition file. So when you share your container with someone, if that someone does run this command, that someone will be able to see how you created that container from scratch, right? But if you do it from a sandbox, what really that person is going to see is bootstrap local from a path in your host, and whatnot, right? So that other peer reviewer won't be able to see how you build your container, right? So it is breaking reproducibility and mobility. So best practice, yeah, play with your sandbox and whatnot, but after playing with your sandbox, go back and create a good definition file. So when you share your container, everyone will be able to see how you created your container. Or if you don't want anyone to see how you create your container, it's up to you, right? So if you run this, you should be able to see the same definition file that you used it for creating the container.
This getting is the base machine, the base container, the Ubuntu in this case.
Mhm.
It's getting from the this cloud. Or, yes.
Sylabs,
You will define your own place.
well, you can just use an Ubuntu ISO image to start from.
Yeah, you see, you
ISO
have-
date for example. So I could tell them to use the ISO, what is the ISO?
Yeah, as a starting point.
So here we're in the exec question. So we have already user playing with exec. So up there we were using singularity with run. Here we are using singularity with exec. So we have used shell, run, and now we're seeing exec. When you do exec, you are not leveraging the run script in the definition file. You are really just jumping into a different file system, and you need to call the strings, right? So you are not going into an interactive shell, but you are changing into a different OS, and then in that OS you need to call the binaries. So if you do this, you should be able to see this. But this is, again, like for playing. A production-ready container should always be calling the run script. So this is just to show how exec works. So exec, show, and run work the same way. They call namespaces, they mount your file system, but the thing that is running at the end depends on if it's run, exec, or show. This is another example of using exec. So here we are doing a piping into a file. If you want to retrieve some information from a running process in your container, in this one I'm going to stop 1 minute. So this is also for those bash scripters in the room, a good way to pass information into a container just by using bash files, right? So this is really showing that if you're using exec, not run, you can pass bash pipes into the container from the host. So cat cosine is being run in the host, and the pipe is going into the container. So then you see the cow calling the cow. Right? So this cow is hearing the file that is in the host, and it is being piped into the container, which is calling this cow with the information that is being piped into. Is people able to do this in their AWS instances?
Could you repeat what we should do in production mode?
Run.
Please run and put the command in the definition file?
Yeah, in the run script here. Yeah, so when you use singularity run, singularity will call everything that you have in the run script. This is a bash scriptlet, right? And why this is production? Because it is going to be repeated every time you use it, because it is hard-coded into a read-only, right? But if you're using exec, you can change whatever you want after the container name, and that's not reproducible, right? Because you can change it every time you call it. But by using run, if you try to do something different, it would fail or it would broke because it's not hard-coded.
The technical point of view is the same, right?
Yeah, again, it's a best practice. It's a recommendation. You can call it with sec, with run. At the end is how are you going to reproduce the same result? How are you going to share that with someone? And being sure that when that someone is just clicking run, will get the same versus, oh, you need to call exec and do this and this, right? So it is removing that burden from you because you just hard-coded it.
Yeah, sorry, maybe I forgot. If I want to run another code, I should create another container and use this almost the same definition file and change the host, right?
Mm-hmm. Okay, now we are going into the why we have the token. So the idea now is that everyone should have a locale file after building the container. So the next section is going to be pushing that container into your account and again using the Wi-Fi to see that your container is in the cloud and you can share with another person. So here, you should have a name. So my name is Sylabs Ed. So you're going to run singularity push the name that you give to the container you just created. I saw a lot of people just using locale without point something or whatever. So you don't singularity push locale library your name. You need to name a collection, so it can be, I always use examples, demo, or something like that for raw images. So your name, a collection, and the container name. Like the newest version of Singularity, it will scream that you cannot push a container that is not signed, right? So this is after some CVs that happened this year, that they are really related to not trusting your container. So the way that we are protecting the library is by not allowing people to push container that doesn't have a, who are you, right? This is me pushing a container. So before running the push, you need to run singularity sign and point again to the container. And it is going to take you step by step to sign that container so then you can push it.
When you do an update and you install a package, again, same issue. And we have faced some issues with how locality numbers, for example. you know, there have been some bugs, so we can break the RPM. So, I don't know, so what's the best practice that you could, best advice that you can do, you can give?
Say it, Eduardo, say it.
Point to Kenneth.
If you use easy build, you won't have that problem because everything is been.
Yes.
Yeah, it's, as Kenneth said, do not use latest. I never will encourage someone to use latest. I just use latest for demos, but not. And try to hard code versions. Do not leave like install package name, because you say like package names using JOM or apt-get, they can be updated without you telling that they were updated. And then you're rebuilding your container, and maybe the JOM is going to bring the newest version.
So, at the end of the day, a container also relies on packages that are developed, for example. And you can use the show duplicates and so on. If you don't have a local repo in your data center, and you throw that repo, it's nearly impossible to develop. And then you cannot export or share the container definition file.
You can download specific RPMs and can install those to hardcode version. At least then you have control. Whether it's a good idea or not.
Yeah, it's
So
a
this-
version of
Yeah, because there's also security side. If you are doing something from RPM, it's because you are trusting that every new release is going to be secure. That, like, yeah, the production-ready containers that I use with my customers, they are a lot of wgets. Wget, so you can get the specific RPM version. I do not trust JOM Silver. I do a lot of wgets, and I install them by checking the signature of the RPM and the hard-coded version. This is HPC, you know, I have customers with kernels 2 point something, things like that. You're like, can you go 4 or at least 3? Yeah, so when you start seeing these production-ready containers, you see a lot of wgets. Like wget me half of the internet, so I can control everything that I'm getting and installing that from RPM. It's a very easy build spec question. Just not using a JOM cipher, but like wget and everything, so you can control, like fine-grained control. How's everything going? Is people having issues creating the signature and pushing? Error message that you could see that I just saw is that when you are creating your PGP key, you need to use the same email that you use it for generating the token. If not, it is going to tell you, your token email and your BGP key email are not the same, so that's not trusted. They are asking me if you can have multiple signatures in a container. You can have as much as you want. You can have 2, 3, 5 signatures on the same container. And for system admins, if this is not for maybe today, so there's a singularity configuration file that we call execution control list. You can create whitelist and blacklist of signatures. So if you go, you can maybe for blacklist, every developer in your company has a PGP key. You fire someone, and you are not secure enough that someone is with access to the cluster, so you just blacklist his PGP keys, and his containers will never run again in that data center. Or the whitelist, so you're telling Singularity only run containers with these PGP keys, and you can create lists. So how do we see users leveraging this feature is you can have multiple steps verifications of a container. So in the whitelist, what you are doing is, I will not run a container that doesn't come with the developer's key, maybe the project leader key, and the security guy key, right? So that way you're having 3 signatures into a container. And when you're running it, if the container runs, it's because it comes with the security guy key, the project leader team, and the developer's key. So if it is missing one of those 3 keys, it will never run, right? So you can create those kind of workflows by using the execution control list. So the Wi-Fi is really slow. What is really next is going to the web page and seeing your container, and how in the web page we show that the container is signed, the container is stored with a SHA-SUM. So even if you screw it up by setting a wrong tag in the container library, it will always live with a SHA-SUM. So you can just call that SHA-SUM forever. About integration, so you just push it to the container library that you can pull, not push, you can pull from different sources in the 3.x version. So the 3 big ones are Singularity Hub, thanks to Vanessa Sokat, Docker, and the library. But in Docker, what is also happening is that you can call OCI registries. So you do Docker // and you can call AWS, you can call GCP, you can call private registries by using the OCI. So when we are telling Singularity to pull from Docker, what we are really doing is that we are pointing Singularity to OCI compliant registries, right? So if you have a whatever Azure, Google, Amazon compliant registry, you can use Docker and pull from that. NVIDIA has a OCI compliant registry, so if you use Docker // NVIDIA, I forgot the 3 letters, NVIDIA GC, MBG, something like that, is the OCI NVIDIA registry. You can pull containers from the NVIDIA cloud.
It seems that we cannot push to this. I am not permitted to create Sylabs set in the library. Which is not in a PTA.
You broke something. I will be back.
I think so.
Yeah, okay.
That we don't have permissions in the cloud.
Maybe the token is not authorized.
Our resident token, what does it mean?
Maybe the token. So now an extra cloud service is the remote builder. So let's say you don't have that awesome AWS instance that everyone has sudo access. It's a really unsecure instance. A lot of companies and enterprises, even with the laptop they gave you, you don't have sudo access, right? You are like super blocked. You cannot call sudo even in your laptop. So thinking on that, Singularity Cloud Services let you build using the remote flag. So instead of doing a -- sandbox as we were playing before, if you use -- remote, it is going to push just the text file, the definition file, into the cloud, and we are going to build a container from that text file and store your container into the library. That way, if you don't have access to a machine with sudo, you can still build containers by using the -- remote. What we are going to evolve this service, so right now it is building in a x86 machine, regular machine. What people is using in academia is installing the remote, so we still call it remote, but the build service in their facility. So if you have, let's say, an ARM data center, you install the build service in the ARM data center, and from an x86 machine, you push your definition file into the ARM data center, and then you're building an ARM container. So the build service is going to be building the container for you in the architecture on which the build service is living. So right now, if you do this, it is going to build a x86 container in an AWS machine. But if you have a build service on-premise in your data center, it can be a Power machine, an ARM machine. You go crazy. Like whatever architecture you have there, the container is going to be built with that architecture. So with the local definition file that we have, so to be more explicit here, I call it the file local def, but I know that a lot of you call it singularity with an uppercase S. If you do this with that file, it is going to build that container in the cloud. So let's try.
This will be done in this machine, virtual machine, or
It's in the Sylabs.
Okay, and what is the limitation? You want to send it for demo or?
Is for development purposes, right? So it's a 2-core machine, 8 gigabytes, and you have 10 minutes. If your container build takes more than 10 minutes, it will fail. So if you work more than 10 minutes, send me an email.
Okay.
And we can have a business conversation, but business here is with Jordan, not me, so. Yeah, but that's the idea. Just to give people a way to test it. And then you can have, as I was telling, the on-premise build service. So the real interest here is, yeah, x86 that I can build in a virtual machine. But what we are having right now is people with Power machines, ARM machines, and all. So it's really hard to give a developer a Power laptop or an ARM laptop. So people are using it like that.
Is there a plan to provide this remote option with the on-premise server? So if I want to build some GPU specific image that I don't want to provide access to the user to our cluster, so maybe it would be nice if I can use that remote option with some way out the on-premise server. So the remote always work with on Sylabs servers, right? So it would be nice if we can have the same function on-premise.
Yeah, on-premise. Yeah, that's what I was explaining here. Like, if you want, we talk in the coffee, and I explain you how the on-premise works. And so the on-premise, we saw that at the beginning when setting up the token. So when you were setting like Singularity remote at Sylabs Cloud, right? Everyone did that step. So that's for the default. But when you have an on-premise build service, library, whatever, you need to configure that. So that's why we have that configuration step that maybe today was like, well, why am I doing this? Is because if you then have you can have multiple on-premise services. Then you just sign them in your machine, and you can point it out to different remote services. So you can store your containers in a remote 1 and build your containers in a remote 2, and also you are playing around with some open source project, and then you point out to the default remote that is the Sylabs remote. So then you can have a full list of different remote data centers and the Sylabs default.
That's commercial.
Is people with the authorized token able to see the logs of a build happening in the cloud? So you guys wrote something. ¿Sí era el token? Ah, rompiste algo. Yeah, so we have always 3 instances waiting for feedback. We have more than 3 people, so we need to call Amazon. So what we do is that we call Amazon, we spin up machines, we build your container, and then we kill the virtual machine. So if it is taking time to retrieve logs, it's because all the available machines are busy right now, and we are spinning up more machines for you. More questions about the remote building service? Did everyone build run? For the ones that it took some time, so we are trying to have between 3 and 5 instances up every time for quickly deployments. And here we have more than 5, so when the 5 are busy, we start deploying extra machines for that. This is a promise of a better Wi-Fi.
Only a promise.
Everyone? Yeah, it's just a promise.
And the password didn't change for 4 years.
I was thinking exactly the same thing. So keep this password for next year, please.
You already used the key store by force, because we are now forcing people to sign containers in order to push into the library. What I want to show here, and you can just play with these commands, is that by using singularity keys, you can create new key pairs, you can store a lot of key pairs in your host, you can list them, you can push them into the key store. So right now, when pushing the first container, you were able to push a key into the cloud. So if you go with a better Wi-Fi into the Sylabs cloud, if everything works, you should be able to see your keys there. It's just the public side of your PGP key. And what's really awesome of that is, now that you have your container in the cloud and your keys in the cloud, you can pull your container from a different host and verify that it's the same container with the same PGP keys. Now we have a full trusted workflow from creating the container, signing the container, moving it around, and verifying that it's my same PGP key. If you are aware of how PGP works, if someone tries to modify that container, the key is going to grow, and then when you're trying to verify the container, it's not going to have the same key. So after this, we have used the 3 different container services that are up there in the Sylabs cloud. So it's the library, the builder, and the key service. The key service is really a hidden feature, like you are using it when you're signing, when you're pushing and pulling, and when you're building containers. But the 3 of them together, they give the users access to a fully secure and trusted workflow from building containers to sharing containers. So any questions up here to the cloud services and how to interact Singularity with the cloud services? So a big reminder is that cloud services only work with Singularity 3 upper versions, right? So if you try to use Singularity cloud services with 2.x Singularity, it just doesn't exist. Like their CLI doesn't have these commands.
How it works with the token and the keys that we generated. I mean, why there are 2 measures of security? Why there is the token and there is the PGP?
No, the token is how you interact with Sylabs.
Okay.
Right? The key then becomes how you can trust your container across different persons. So the token is just between you and Sylabs. Your keys, then you can share it around with different users, peer reviewers, or whatever. So it's a different channel of communication. Right? What we are trying to enforce is that the information you use when creating the token should be the same information you use when creating the keys. Right? So if you try to create your keys, your PGP keys, with a different email that the email that you use it for the token, it is going to say that that is not possible. Right? It needs to be the same email.
How are we on time?
So I'm open to questions. Yeah. I have 10 minutes for questions and more advanced use cases. I'm really happy that we made it all the way up to the cloud services. Sometimes with 3 hours, I don't reach the key score.
Does singularity work with checkpoint? Assuming that somebody's been trying to get into the MTCP. I'm just wondering what the status of that is.
Checkpointing during the build of the container or during the run?
When you run it.
No. There is a big GitHub issue on how to do it, but as a singularity default feature, we don't have a checkpointing. It's being discussed how to add checkpointing into containers as you can do it with virtual machines. So far, I haven't seen a production-ready container that allows you to do checkpointing, and more even in the HPC ecosystem.
But there's a tool called Cryo. There's a tool called Cryo, and if you use Docker checkpoint, then you can checkpoint all the file system descriptors or the memory and so on. It's a little bit cumbersome, and it's not really something you can use.
I've seen some efforts there, but there is no like production-ready feature that allows you to do the same that you can do with virtual machines. Like same, like a VMware, vSphere checkpoint.
Is there
Supervising containers with singularity? Yeah, so for it, so that's instances. It's really fast. It's really slow to run all these tutorials, but you can run it. So here you can see how you can create instances and check them where are them. So you can have services like Min.io or a database or Nginx.
So on it was more a comment about the checkpoint you understand. So if you don't want to rely on checkpoint you understand at the kernel level or at the container level, so by taking advantage of checkpoint you understand natively from the application point of view, like if you're using Andy or molecular dynamics or Fluent or whatever, so you can infer exactly the same strategy that you do in other words, we say models. So it's not a big deal for something like that. So you just put the shuffle system for dumping the checkpoint and then you restart from scratch as usual.
Yeah, checkpointing for me is still exploration realm.
It's a very important use case.
No, I know that it's important.
Especially on an HPC cluster.
I just
At the kernel level, it's so consuming. So dumping gigabytes of data for all the news that you have in the shuffle system, and to record that from scratch, it's quite demanding in the shuffle system.
Well, that's why you have something like Master.
Something like Lastar. Yes. So yes, you have something like Lastar or Gutierrez or other classical systems, but the reality is that either or you have a very fast disk in the backend, like no molecular memory disk, you need to digest this amount of data, or it's nearly impossible to. You can lock down the cluster for rather than the IO, and nothing else can go in there. You can do the classical system. So, and rather than using kind of a mechanism to improve the reliability of the cluster, you are using potentially and instability. So you have to learn this very carefully. So that's why application level, it consumes much less resources because you have like a state files, and then you can potentially start this consuming just few megabytes or few gigabytes.
Yeah, I appreciate it. And I know it's super important.
Okay, can you do it from the outside though? Can you checkpoint singularity? What you were talking about is having checkpoint support inside of singularity. You can probably checkpoint
Just check on the
yeah, just
The process.
start it and then singularity run or whatever, and then checkpoint singularity itself and everything. That would make it work.
Not even singularities. As I always say, the high-level overview of singularity is that really singularity kicks the binary into the process pool and goes away. So once you start running the process with singularity, what you have is a process ID in the process pool. So if you can checkpoint a process ID,
It's a regular process. Once singularity has done its magic, it's nothing really special. But it's going to work.
more questions?
Is there a way to build a singularity image from local? So, with what kind of command?
I will show this afternoon. You can use
Oh.
local image as a bootstrapping.
In the bootstrap section, when I was explaining that you can have different sources, one of the bootstrap sources can be local. So you can point to a local tab.
Local image.
Oh, local Docker image?
Yeah, so sometimes
Yeah, you can build from a running Docker container, from a local Docker container, or from a local Docker registry. It just depends on how you set the bootstrap and the form in the definition file. But you can do it. This is as far as you get from me, then you will have Ken in the afternoon. Thank you. If you have more questions, I'm free, having a lot of coffee, eating jet lag. So thank you again, and thank you for bearing with me with the Wi-Fi and whatnot. The GitHub repo is up there. I will try to, I always set myself one day every month to update it. So it will be updated once we have new features. You can just run the tutorial at home.